Okay, so now what you're going to do is find an expression for the maximum number of people who will be infected at any time. Alright, so this is what we have for di of t over ds of t is minus 1 plus r times c, r over c times s of t. So what we will do is now the to find the maximum we will set this di of t over ds of t to be 0. So this is like the slope of the line of the curve. Okay. So when we set this to 0 we find for what value of say s of t we'll find the maximum of I of t. So now that we saw that I of t is a function of s of t in the previous video, we want to find for what value of s of t is this I of t going to be the maximum. So that's what we want to do. So from kind of like math, we know that if say you have a differential of say I of t over differential of s of t, we want to find the maximum of for what value of s of t is I of t going to be the maximum. We set this differential to be equal to 0 and solve for s of t on the right hand side, and that's what we're going to do. So we have here di of t over ds of t is minus 1 plus r over c times s of t. So now we can set this to be 0, so we'll solve now for s of t. So negative 1 plus r over c times s of t equal to 0. That means r over c times s of t equal to 1, and s of t then will be equal to r over c. And we define also this q as c over r. So r over c will be simply 1 over q. So when s of t is 1 over q, I of t is going to be the maximum. That's what we can say. So we have this general equation relating I of t and s of t. So now substitute s of t equals 1 over q in this equation. So what we will have then is Imax is minus 1 over q plus n plus 1 over q times log of s of t is 1 over q times s of 0. Now try to simplify this equation. So I can take so if I want to move this q to the numerator, I will make this a negative sign. So minus 1 over q plus n. Now 1 over q, if I want to move it up to move the q to the numerator, I can make it as minus log of q over s, q times. So this thing q times s0, if I want to take it to the numerator, 1 over this. So log of 1 over something is minus log of that thing in the numerator. So q times s of 0 goes to the numerator. So minus 1 over q times log of q times s of 0. So now this 1 over q is like a common term here. So n minus 1 over q times, for this 1 over q we have a 1 because it's 1 over q times 1, so minus 1 over q. Then plus for this 1 over q we have log of q times s of 0. So Imax is n minus 1 over q times 1 plus log of q times s of 0. Now I'm going to call this q times s of 0 as what is called as r hash, and write simply it as 1 plus log of r hash. So this r hash is called the basic reproduction number, and we can define this r hash as let me see, it's a measure of the number of secondary infections a primary infectant can spread at any time, right? So we saw that earlier. So we would like to keep this r hash to be less than 1 for an infection to die down. If r hash is greater than or equal to 1, it will spread. Okay, so again the basic reproduction number tells you if there is an infectant, so we call it as this primary infectant, how many more people or how many other people, how many people that person can cause infection to. So it's called secondary infections. Okay, so that is this estimate of r hash. Sorry. Okay, so now we have our hash to be q times s of 0. And what is this q? Q is always c over r. So c times s of 0 over r. So that's q times s of 0. Alright, so now you can see Imax is n, which is the total number of people, that is the total population, minus this term. So what we can say is, now this is the maximum number of people who will be infected at any time. So that's going to be n minus this term. So this second term here is going to be the minimum number of people who will not be infected at any time. Okay. So we can say this 1 over q times 1 plus ln of r hash is the minimum number of people who are not going to be infected at any time. So not infected people, the minimum number of not infected people. And we would like to keep it as large as possible so that n minus of that is going to be smaller. So that means we can keep the Imax smaller. We can keep the maximum number of people to be infected at any time could be to be as small as possible if you increase the value of this term and make it as close to n as possible. Alright, so you see here I'm plotting here this r hash versus the minimum number of people who will not be infected at any time. So I am having r hash values, and q is r hash over s of 0. And we are now looking at the US population. We have roughly about 350 million people. So n, the total number of people, is 350 million. Now assume the entire population will be susceptible. Then S0 or S of 0 equals n is 350 million. Alright, so then using the S0 value and the r hash values, I'm running it for different r hash values, you can now calculate the q values. So these are the q values. And then plug in q and r hash here, you can calculate the number of people, the minimum number of people who are not infected at any time. So you can see here, if r hash equals 1, you have the entire population to be not infected. That's the minimum number of people not infected at any time. Now as r hash increases, you see that this value decreases. The minimum number of people to be not infected at any time starts decreasing. So that's why we would like to keep r hash to be 1 or lower than 1. Okay, and as r hash increases, the infections will start spreading, and as r hash increases to a very large value, your Imax will become larger. So here I am showing the extension of this. So this is now the number of people not infected at any time in minimum. So n minus of that. So 350 million minus 350 million is 0. Then 350 million minus 296.3 million is going to be 53.7 million, and so on. So as this term decreases, Imax will increase. So you can see when r hash is 20, about 280 million of the population out of 350 million is going to be infected, the maximum number of people who will be infected at any time. So you can plot it as r hash increases, the maximum number of people who will be infected at any time also increases. So the population of 350 million, you can see it goes up to like 300 million for r hash of 20. Now we can also see that this curve kind of will flatten. It's not going to keep on increasing exponentially. So as r hash increases, the curve will kind of flatten. So the maximum number of people who will be infected at any time will eventually kind of become a flat value. Flat means a constant value. Almost, but not like a complete constant, but it will kind of, this rate at which Imax will increase will slow down. Okay. Right, so we'll stop this and we'll see this problem in another video.